Okay, here we have, I'd say, quite a classic question in terms of the approaches that are taken here. We're looking at a block of ice. That's a big block of ice there with water on top. And we're asked to think about the interaction between the water and the ice, the smaller mass of m of water. And we're being asked essentially through that interaction to think about what mass of ice is melted as a result of heat flow. So, as usual, hit pause, have a go, and then hit play when you're ready to see the answer. Okay, so I'm assuming you're ready to go. So in this kind of question, I always recommend my students to use the following approach, which is energy conservation, but perhaps not in a way that they're particularly familiar with. As we have heat flow here and two objects, I like to write that in this way, where we have the heat gained or lost by object 1 added to the heat gained or lost by object 2 is equal to 0. So essentially this is a declaration of the principle of conservation of energy, but perhaps in a slightly different way to one you might have seen in lessons. Now, the reason we do this is because of minus signs, and we're going to come on to that in a second. So if we're thinking about these, and again, I appreciate it's quite a big jump here, we're going to think about two types of energy. In terms of the ice, which we're assuming is staying at its constant temperature, it's going to change state. So we're going to have to think about the latent heat, that's L delta M. Now delta M is our mass that's going to melt as a result of the heat flow. We then got MC delta T, where M is a mass of our water, and we've used the same notation M here. Now notice, in this case, we've got the two things adding up together. One of them is going to be negative because we've got positive plus negative equal to 0. I'm then going to substitute in delta ML. I'm just going to bring MC delta T on the other side. Now delta T, we've got a change in temperature, and this is where those minus signs work. Our final temperature is going to be 0 because the water is going to cool down from its initial temperature. That's the final temperature is 0. Its initial temperature is T. We've got 0 minus T minus MC times 0 minus T just gives MCT. We're then going to rearrange our equation. We've got delta ML equal to MCT, or in other words, delta M is equal to MCT over L, which is why the answer here is A. Now, I'm sure there's another way you could do this through dimensional analysis. Okay, if you were, for example, to take the dimensions here, I think these answers B and D wouldn't work, or yes, they certainly wouldn't work if you're just having a look there in terms of units. So you could have a straight up check there in terms of A and C. However, I'll leave that as an exercise for you guys to try.